Welcome to this video in the course, friends. We're going to develop the formula for finding distances in three-dimensional space. Hopefully, because you are doing this, you already are familiar with the basic Pythagorean theorem because we will make use of it here twice. That's all. So let's get going. First, we're going to build up a coordinate system. That's our first process. So make an axis, and then an axis. Let's label things clearly. We'll call this the x-axis as usual. We'll call this the y-axis, and of course this will be called the z-axis. Now within this coordinate system, we're going to find the distance between 2 points. So I need to first just pick a point somewhere. It doesn't really matter. Pick a point, and then pick somewhere another point, say out here. We need to label these. So the ending point will have subscripts of 2. So I'm going to call this x sub 2, y sub 2, and I'm going to call this z sub 2. X sub 2, y sub 2, and then z sub 2. I'm going to make that a bit smaller so it fits better. The starting point, add some coordinates to it. Then it's going to be x sub 1, and then y sub 1, and then z sub 1 this way. And then you're going to make that a couple times smaller this way. Now from here, I'm going to proceed as follows to find the distance from this point to this point. I'm going to first draw a triangle in the xy plane. In other words, a horizontal triangle with respect to the xy plane. It's going to have a leg going this way, and one going this way up to about here, and then another one going this way to about right here, see? And then I'm going to draw another triangle. We'll take it from here up to that point about. So let me just refine my picture. I'm going to remove this so it looks a bit better. There we are. In this context, the following is true. We have to label things better. What are the coordinates of this point right there? We need to know those. So those coordinates are the following. You're moving only along the x-axis from x1, y1, and z1 towards where the green arrow is pointing. So you would do that then as follows. You would say x sub 2. So x is the coordinate that changes. Y sub 1 and z sub 1 do not change. So y sub 1 does not change, you keep it. And then z sub 1 does not change. You are in the same number of units above the xy plane. Same thing with y sub 1. You are the same number of units away from the origin along the y-axis. But the x sub 2, that does change because you're moving kind of out of the page, so to speak. Let me make this a bit smaller so it fits better. That's this point. Now, we can mark a separation that looks like the following. To find the distance along that piece from x sub 1 to x sub 2, you're going to say an absolute value. X sub 2 minus x sub 1. That's the length of that segment right here. Again, let me make this smaller so it fits better. That's this segment. This segment right there in that position. Then I'm going to turn here, and remember that this is a 90-degree angle. Because we're looking at it from an angle or from a different perspective, it may not look like it, but it is that. So this is meant then to be a 90-degree angle right here, this right here, okay? So we're dealing with a right triangle parallel to the xy plane. So you're going to turn at that mark, and you're going to go over to here. So now we need to describe the coordinates of this point in some fashion. So notice the following. I'm moving along that black line, parallel to the y-axis now. In that line, the x-coordinate is x sub 2. The y-coordinate you might now call y sub 2, but the z-coordinate is still z sub 1. It's not z sub 2. It's like this. It's z sub 1. The reason is that this black triangle, remember, is parallel to the xy plane. It doesn't matter where you go on it. The y-coordinate does not change. Therefore, it's z sub 1 here, it's z sub 1 here, and it's z sub 1 there. It's z sub 1 everywhere, in other words. But this segment where the green arrow is pointing towards where the red arrow is pointing, that segment clearly changes as you move along the y-axis, so the y-coordinate gets changed from y sub 1 to y sub 2. Which means that this length right there of that segment, an absolute value, you would describe by saying y sub 2 minus y sub 1. Let me make this a bit smaller so it fits better. There's one last piece here. When at the red arrow here you turn and you go straight up along the green segment, well, that would be described by saying the following. An absolute value, that would be z sub 2, which is the z-coordinate at the end of it, minus z sub 1, which is the z-coordinate on the bottom. So that would look like the following then. Let me make this smaller again so it fits better. Let me also emphasize this again right here. This would be a right triangle right here. See this? Okay, it's just the perspective that makes it not seem so. When we look at this picture, we see we have two right triangles. We would like to be able to find the length of this segment right here. The length of that segment that joins our original point to our second point. So I'm going to proceed by doing the following. I'm going to make this a bit thinner here. This line, that first hypotenuse, you can find that by using the Pythagorean theorem as follows. Square root of the following. You're going to do the sum of the differences of the coordinates squared. So it's going to be x sub 2 minus x sub 1, this quantity squared, and then plus, and then y sub 2 minus y sub 1, this quantity squared. That's the length of the following. Let me emphasize that. I'm going to make that blue, okay, of that blue part of the triangle. With respect to the vertical looking triangle, where one of the legs is that green piece, that becomes the following then, in terms of the final formula that we need. I'm going to write it over here, okay? Follow those arrows. It's going to be the square root of the length of the blue one, but we already know what that is. Right? You're going to square the following right here. You're going to take this and you're going to square it. That's the distance or the length of the blue one, and you're going to add to it that's z sub 2 minus z sub 1, and you're going to square that this way. So this is another use of the Pythagorean theorem after the first use of the Pythagorean theorem. That's allowed. And then here, what you're going to do next is just simplify this expression. So it's going to be the square root. Look under the giant square root, so to speak. See, this 2 right there will cancel with that square root right there, because they're opposites, which means all that will be left over is the following then. X sub 2 minus x sub 1, this quantity will be squared, plus y sub 2 minus y sub 1, this quantity will be squared, plus z sub 2 minus z sub 1, and this quantity will also be squared. Unfortunately, it went off the page, you see? Let me just kind of move it into view. And then this object is called the distance, okay, formula, okay, for points in 3D. It's based on two uses of the famous Pythagorean theorem, in other words. Thank you, friends. I hope it's been helpful. Please leave a like, please subscribe. I will see you in another video.